Hello, beautiful people, and welcome. In this video, we are talking about the special right triangles and their relationship with the unit circle. Now, if you recall the special right triangles, those are the 30, 60, 90 triangle and then the 45, 45, 90 triangle. Now, I did split up the 30 and the 60 triangle into two separate triangles, just so that way we can see that the theta or the eyeball is different. So, for example, this theta, this eyeball is 30 degrees. This theta, this eyeball is 45. And this theta, this eyeball is 60 degrees. Now, if you recall our previous videos or our previous units where we said that, hey, if we have a 30-degree triangle, that means across the street from that 30 degree is our value for x. If we have a 45-degree across the street is our x. And then if we have a 60, now 60 is a little bit different, so I'm going to hold off on that. So let's go back to our 30-degree triangle. So if we have 30 degrees, across the street is x, that means our hypotenuse is x times 2. And our leg right here, this longer leg, is x times root 3. Now for the 45, 45, 90 triangles, because we have an isosceles triangle, that means the legs are congruent, and that means the angles are also congruent here. That means if we have an x on this side, that means we have an x here. And we have x times square root of 2 for our hypotenuse. Now 60 across the street from 60 is going to be our x root 3. Here's our 30-degree angle. Our hypotenuse is still 2x. And then across the street from this 30 is our x. Now I did cheat a little bit. I usually look at the 30 degrees and then cheat here for the 60. Now what does that mean with the unit circle? We kind of already know this. Well, the unit circle, think about the name, unit. The unit circle represents 1 unit. And that 1 is the length of your hypotenuse. So the length of your hypotenuse for all of these triangles is 1. And that's not a 7, that should be a 1. So what that means is that the values for the legs, that's a 1. The values for the legs, they also get changed. So let's start with the 45, 45. If we have a 1, that's equal to our hypotenuse. If you're in my class, we did these simple problems. We did a lot of these problems actually. That means this right here is root 2 over 2, and this side right here is root 2 over 2. If we have 1 as our hypotenuse, that means I'm going to divide by 2. X is equal to 1/2. And 1/2 times root 3 is root 3 over 2. And again, that means x is 1/2 here, and that means we have root 3 over 2. So I'm going to redraw the triangles here real quick. For our 30-degree triangle, we have a hypotenuse of 1. Let's actually change that to a different color. We have a hypotenuse of 1. We have a leg of 1/2, and we have root 3 over 2. Let me shift that up just a little bit. For our 45, 45, 90 triangle, we have a hypotenuse of 1. Our leg is root 2 divided by 2, and our other leg is root 2 divided by 2. And for our 60-degree triangle, our hypotenuse is still 1. We have root 3 divided by 2 and 1/2 here. Okay. Again, why does this matter? Well, these triangles are extremely important because of their degree value. We have a 30, a 45, and a 90 degrees. So if we look at the unit circle, the unit circle, the unit means 1, right? 1 unit. The distance from 0 to any point on that circle is going to be 1. So here's 1. And again, the distance from 0 to any point on that circle. So if we do 1 here, that's going to equal to 1. And if we do 1 here, that's going to equal to 1. And if we do 1 here, that's going to equal to 1. All of this is the hypotenuse to your triangles. So all of these lines here are equal to 1. Now, if we focus on quadrant 1, so here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If we focus on quadrant 1, you can kind of see that we have these triangles embedded in here. So I'm going to draw this down here, draw this down here, and draw this down here. So for our first triangle, this triangle is going to be our 30-degree triangle because it's the smallest degree. So you have 30. Then we have our second triangle in here. Here's our second triangle. Now this degree is from the x-axis, and that's going to be our 45 degree. And then our third one is going to be our 60 degrees. And that's going to be here. So what you have is in quadrant 1, and let's draw it again real quickly. In quadrant 1, we end up having 3 triangles. Again, let's just draw quadrant 1 here real quick. So we have, here's our unit circle. Let's try to draw it here. Here's our 30 degree. Here's our 45. And here's our 60. Now it is the distance from the x-axis. So it's not like the little sliver. It's not like this piece right here is 45. It's the entire piece all the way to the x-axis. So in reality, it's kind of like you have your triangles drawn out like this, and then you label them. So here's our 60, here's our 45, and here's our 30, with this point being on the actual circle. Now, why does this matter? Well, this matters because these 3 triangles can be copied and pasted all throughout the unit circle. So if we do quadrant 2, so let's do quadrant 2. Here's quadrant 2. And I'm going to take and copy these triangles in quadrant 2. So let's say I take my 60-degree triangle. So here's 60 degrees, here's my 1, and here you have 60 degrees. What about our 45 triangle? Here's your 45-degree angle. And here's your 30-degree angle. And you can draw it there. Now what's great is you can keep doing that to all of your quadrants. In quadrant 3, we can have our 30 degrees. We can have our 45 degrees. We can have our 60-degree triangle. And in quadrant, just to make it all connect, in quadrant, here's your 30, quadrant 4, here's your 45, and here's your 60 degrees. So you have all of these triangles, all 3 triangles in every single quadrant. And what's really cool with that is you can have a different measurement, however, have the same triangle values. So let's talk about the unit circle values. The unit circle has an x and a y just like every other graphing, Cartesian plane, things like that. And let's draw that one again. I'm not sure if that's any better, but let's just go ahead and stick to it. This point right here is 1, 0. This point right here is -1, 0. This point right here is 0, -1. And this point right here is 0, 1. Just like our usual points. Let's try to zoom in just a little bit. Now remember we have our 3 lengths. We have our angle sizes. We have a 30, we we have a 60, excuse me, we have a 30, we have a 45, we have a 60 right here. And each one of them has a value of the location of the point. Now the hypotenuse is 1, but this location is your x and y, x and y, x and y, whatever that location may be. Now what's really cool is if we go back here to our unit circle, these ones in pink, these x's and y's come from your horizontal and your vertical. So horizontal, if we're looking at a 30-degree angle, your horizontal is your x and your vertical is your y. So it's kind of like saying your x and y comes from these values. Here's your x, here's your y, here's your x, here's your y. So for all of these points, your x and your y, they kind of come with it. Here's your x, here's your y, and here's your x, and here's your y. So when you're writing out the unit circle, I'm going to grab a little bit more paper. Those values come with you. So let's shift this up. Let's see if I can draw a better circle than I previously did. And again, I want to focus on quadrant 1 because if you know quadrant 1, you know all of them because all you have to do is copy and paste those triangles. Let's try to draw a circle. Here are our 3 different lengths. We have 30 degrees, 45 degrees, 60 degrees. Now, if we continue, this one right here is super important to know. This is 90 degrees. This is 180 degrees. And this is 270 degrees. And this is 360 or 0. And we can continue those rotations. So if we look at the right triangle, I have it here, and we look at the 30 degrees, our x value is root 3 over 2. Our y value is 1/2. For our 45, our x value is root 2 over 2. Our y value is also root 2 over 2. And for our 60s, I have x is 1/2 and y is root 3 over 2. And immediately you're going to start notice some sort of similarities. Notice that for 30 and 60, one of them is root 3 over 2, the other one is 1/2. It just happens to be flipped. Well, if you look at a 30, 60, 90 triangle, notice that 60 and 30 are kind of flipped. Here's 30, here's 60, and then you flip them. And so that is why your x's and y's for the 30 and 60s are flipped as well. Now, if we continue the unit circle, the 30, 45, 60, 90, they don't necessarily stay the same. The triangle stays the same. These are called your reference angles. Now, for the reference angles, when you have those, they're going to be different, but the location is going to be different. But the value, the x and y value is going to be the same. So what I mean by that is if we continue to count, we have 30, 45, 60. 60 plus 30 is 90. 90 plus 30 is 120. 120 plus 30 is 150. Now notice that I did skip this one right here. That's because the distance from 120 to 50 is 30 degrees. The distance from 150 to 180 is 30 degrees, but we need to travel that 45. So I'm going to come back and fill in that 45 in a little bit. Now there will be a separate video on the unit circle and how to fill that out. I just want to show you how important it is to know these values. So with those values right there, we have to go back in 45. So 45 plus 45 is 90. 90 plus another 45 is going to be, and I'm drawing a blank here, I apologize for that. That's 135. And for your x's and y's, because your hypotenuse is still 1, the location did change. Obviously, we're not in quadrant 1 anymore. We are now in quadrant 2. So you're going to take these values, copy and paste, copy and paste, copy and paste. So because I have a reference angle of 30 degrees, that here's my 30-degree triangle, here is my 45-degree triangle, here is my 60-degree triangle. Because the triangles are copied and pasted, the X and Y of those triangles, they stay the same. I could just take this triangle right here, this 30-degree triangle, cut it out, flip it over, and the X and Y stays the same. Nothing really changes. So that means root 3 over 2 and 1/2 stays the same. For the 45-degree triangle, here's 45 degrees, root 2, X and Y, that stays the same. And then for our 60-degree triangle, our X is 1/2 and our Y is root 3 over 2. So that doesn't change. And if I had 3 more triangles here and 3 more triangles here, those values don't change. Here's your 30-degree triangle, here's your 45, here's your 60. Here's your 30-degree triangle, here's your 45-degree triangle, here's your 60. Now, the only thing that does change, because now we are in quadrant 2, is that in quadrant 2, your X values happen to be negative. So we want to go back to all of our X values and put a negative in front of them to symbolize that, hey, in quadrant 2, our X values are indeed negative. All right, beautiful people, that is it for this video. The next video will go through all of the unit circle and how to memorize it. Thank you so much for watching. Take care. Bye.